Today we'll be working on hypothesis testing, and this is the part of the inferential statistics. We are going to begin with some fundamental terms related to the hypothesis testing, and then later on we'll explore the examples on hypothesis testing. Some key terms that we need to know in hypothesis testing. When I say hypothesis testing, it is a statistical procedure in which a choice is made between a null hypothesis and alternative hypothesis based on information in the sample. So the fact is, in statistics, although we'll talk a lot about population, we'll only have the small sample and we'll be analyzing that sample to predict about the population. So what we'll do here is we'll formulate the null hypothesis and an alternative hypothesis based on the sample, and then the choice is made between the null and the alternative hypothesis. But what is hypothesis? When you want to know what actually is hypothesis, it is the conjecture about the population parameter. It's a way of predicting about the population parameter. Although we have no idea about the population, we can use the sample, we can formulate the hypothesis, and we can talk about the population parameter. So whenever we say hypothesis, it is a conjecture about the population parameter. And as mentioned up here, there are two types of hypotheses. One is called the null hypothesis. When we write this down, we write this as H sub 0, null hypothesis, and alternative hypothesis, H sub A. That's how we denote the null and the alternative hypothesis. So there are two types of hypotheses, null hypothesis and alternative hypothesis. Null and alternative hypothesis, we are going to go to a little bit detail of this one. When we say a null hypothesis, this is these two hypotheses, null hypothesis and alternative hypothesis. By reading the problem, you have to write it yourself. And as I mentioned earlier, the null hypothesis is denoted by H sub 0. That's how we denote the null hypothesis. And it is about the population parameter. Whether we talk about the null hypothesis or alternative hypothesis, both are about the population parameter. You can see both are about the population parameter. But null hypothesis is assumed to be true unless there is a convincing evidence to contrary. So we always consider that the null hypothesis is true. But if we get the opposite result later on, we reject the null hypothesis. And alternative hypothesis, it is the contrary to the null hypothesis. So whatever is mentioned in the null hypothesis, it is the opposite of that. And it's accepted as true only if there is a convincing evidence in favor of it. So always remember, when we have the null and the alternative hypothesis in hypothesis testing, let me write here. Suppose we have a null hypothesis. It is something, we don't know what is that right now because we don't have the example. And we have the opposite of that, it is called the alternative hypothesis. What we consider is, we consider that the null hypothesis is true. We assume that it is true, but we are not going to say that it is always true. Instead, we are going to perform the hypothesis testing. And if we have the convincing result, then we say that the null hypothesis is true. So we either accept the null hypothesis, okay, we accept the null hypothesis, or we reject. So always what we try to do is we try to reject the null hypothesis. We try to reject the null hypothesis. We assume that it is true, but we'll perform the test and we try to reject this. You may or may not be able to reject this. If you are not able to reject this, then we say that we fail to reject. If we cannot reject it, then we say that we fail to reject the null hypothesis. Null hypothesis. So writing null hypothesis and alternating hypothesis, performing the test, and then we'll make the conclusion. So this is the fundamental of the hypothesis testing. The first and very important thing is you must know how to write the null hypothesis and the alternative hypothesis. Null hypothesis, if it is denoted as H sub 0, then alternative hypothesis is denoted as H sub A or sometimes H sub 1. That's the way of denoting the alternative hypothesis, H sub A or H sub 1. Now let's go a little bit detail in how we write the null and the alternative hypothesis. So this is the kind of procedure that we need to know. Test procedure is based on initial assumption that the null hypothesis is true. As I mentioned in the previous slide, we assume that the null hypothesis is true. It's just an assumption. We are not saying that this is true. We will perform the test and we'll make the conclusion. But the initial assumption is the null hypothesis is true. And the other important thing that we must know when we write the null and the alternative hypothesis is null hypothesis always contain equality sign. Null hypothesis has equal to sign, contains equality sign. For example, if you look at the example here, null hypothesis, H sub 0, the average, the population average is equal to some K. See, there is equal to sign. Null hypothesis, it has equal to sign. Null hypothesis, it has equal to sign. Always remember, when you write the null hypothesis, you have to write this by yourself by reading the problem. It must contain equal to sign in null hypothesis. Whereas in alternative hypothesis, based on the information given, it should be the opposite of the null hypothesis, because null and alternative hypothesis are opposite of each other. Null and alternative hypotheses are opposite of each other. So the alternative hypothesis could be, if the null hypothesis is mean equal to some constant, it can be mean not equal to constant. That is opposite. That's not the same thing. Or maybe if I'm saying mu is equal to some constant value, it can be mu is greater than constant. It can be greater than, or it can be less than. So always remember, null hypothesis has equal to sign, whereas the alternative hypothesis may be one of these three. It may be the population parameter equal, not equal to constant, maybe greater than some value or less than some value. And also, based on this information here, when we perform the hypothesis testing, the hypothesis testing could be two-tailed test. You can see the name there. It can be two-tailed test. Just a second. It can be two-tailed test, right-tailed test, or left-tailed test. And how we determine that? We determine the tail, whether it is a two-tailed test or right-tailed test or left-tailed test, by looking at the alternative hypothesis. Whenever you see the population parameter is not equal to, whenever you see not equal to, it is two-tailed test. Meaning of that is you have certain area on the left tail, and also you have certain area on the right tail. Make sure you mark this. Okay, that is a two-tailed test. Now, here you can see the alternative hypothesis as greater than. When you look at the x-axis, the greater value will be on the right. That's why this is the right tail test. So your area is on the right. This area is on the right tail. And then for the left tail test, because we have less than, the less values are on the left. So your area is here on the left tail. So because the area is on the left tail, it is called the left tail test. Because the area is on the right tail, this is the right tail test. When you have area on both tail, it is the two tail test. So one tail test, there are two cases. These two, second and third, these are one tail test, and this one is two tail test. Because we are performing the hypothesis testing, the reason on the tail, this reason, it is called the rejection reason. This is the rejection reason. And that one on the tail, that is the rejection reason. So the reason on the tail, that is called the rejection reason. Let me write R for rejection reason. This is the rejection reason. Then this area in the middle, or this one here, or this one here, that is the acceptance reason. This is acceptance reason. That is the acceptance reason. So this is acceptance reason. This is acceptance reason. So based on the given information, whenever we are performing the hypothesis testing, we have to write the null and the alternative hypothesis. Then by looking at the null and the alternative hypothesis, we can determine whether it is a two-tail test, right-tail test, or left-tail test. Then we have to draw the proper diagram to represent that test. Next thing that we want to know is the errors in hypothesis testing. When I say errors, meaning of that is the wrong decision that we make in hypothesis testing. Sometimes while performing the hypothesis testing, we make wrong decisions. Okay, wrong decisions. And the wrong decisions are called the errors in hypothesis testing. For example, let me write two cases here. You have the null hypothesis and you have the alternative hypothesis. I'm just writing two different cases here. Null hypothesis, alternative hypothesis. Now, suppose you reject the null hypothesis, but the hypothesis was true. See, for example, the null hypothesis was true and the alternative hypothesis was false. Suppose that was the case. But what you did is, when the null hypothesis was true, null hypothesis is true, but you reject. You are not taking this. It was true, but you are not taking it. You are rejecting the null hypothesis. That means you make a mistake. It was true and you are not taking it. You are making a mistake. That error is called the type 1 error. That is called the type 1 error. Always remember, when we say type 1 error, it is the error occurred when the null hypothesis is true and we reject the null hypothesis. That is type 1 error. The second type of error could be the null hypothesis is false. For example, the null hypothesis is false and alternative hypothesis is true. But what you're doing is null hypothesis is false. You're rejecting it. It was false. See, null hypothesis is false and we fail to reject this. If it is false, we have to reject it. But what we are doing is we fail to reject. In that case, type 2 error will occur. It was false, but you are taking it right. That means the error occurred there is type 2 error. In other two cases, that is, you reject the null when it is false, that is a true decision. You fail to reject when it is true, that is also the correct decision. These two are correct decision, but these two are false. If the first one, whenever we have the type 1 error, you are rejecting the null hypothesis when it is true. And in type 2 error, you fail to reject the null hypothesis when it is actually false. So those are the two types of error that might occur when performing the hypothesis testing. And they are called the type 1 error and type 2 error. Sometimes the type 2 error is also called the power of the test. Sometimes this one, type 2 error, is denoted by beta, and it is also called the power of the test. Power of the test. This is just the introductory statistics. In higher statistics, you'll explore a lot about type 2 error. But in this course, you just have to know what is type 2 error. The type 2 error will occur when we fail to reject the null hypothesis when actually it is false. Now we are going to discuss p-value method for hypothesis testing. There are several different methods for hypothesis testing. The very widely used method and the traditional method is called the critical value method. Critical value method. That is first way of performing the hypothesis testing. The second is called the p-value method. P-value method. And then the third one is called the confidence interval method. Confidence interval method. So there are three important ways of performing the hypothesis testing. If you look at your textbook, you will see all these three methods in detail. But what we are going to do is we are going to use the p-value method. We'll be exploring only the p-value method. And you must know these steps in performing the hypothesis testing using p-value method. So critical value method and confidence interval method, these are the traditional method. When we don't have very strong computer system, at that time they used to use critical value method and confidence interval method. But after the invention of the computer and calculators, p-value method, the use of p-value method is increasing. That's why we are going to explore p-value method. So what do we do? Let's find it out. Let's know these 5 steps. Step 1, okay, first step is to identify the claim. By reading the problem, what is the claim? And then we have to state the null and the alternative hypothesis. That's your first step. Or in first step, what you'll do is you'll read the problem, identify the null and alternative hypothesis, and out of this null and alternative hypothesis, one of them will be the claim. You can read the problem and find that out, and then mark that as a claim. That's your first step. Then the second step is calculate the test statistic. Calculate the test statistic. When I say statistic, it is the information related to the sample, either using the data, if they have given the data, by using the data, or by using the statistic provided. We have to find the test statistic. That is the second step. Because you have the information about the sample, we can easily find this. Then number three, we have to find the p-value. Find the p-value using calculator, okay, or by using, normally we use calculator. If not, we also use table, but we will not be using any table here. So we have to find the p-value. When I say p-value, remember this one. This is kind of tricky for you, but this is not that difficult. When I say p-value, it is the total area on the tail. This is the total area on the tail. Total area on the tail. If it is two-tail test, it is the sum of area on the two tail. If it is a left tail test, area on the left tail. If it is a right tail test, it is the area on the right tail. That is your p-value. So find the p-value using calculated test statistics. Generally, p-value is the area in the rejection region or in the tail region. So very important for you to know. Then after that, after we have the p-value, fourth step is to compare the p-value, okay, compare the p-value with the significance label alpha. This significance label will be given to you in the problem. So you have to test the, or you have to perform the hypothesis test as at maybe 5% significance label. In that case, alpha will be 0.05. Or maybe at 10% significance label. In that case, alpha will be 0.10, and so on. This value will be given in the problem. So you have to compare your calculated p-value with the significance label. And if you find that the value of p is less than or equal to alpha, in that case, we reject the null hypothesis. Remember the first case. What do we do? If value of p is less than alpha, less than or equal to alpha, we reject the null hypothesis. Whereas if the value of p is greater than alpha, we fail to reject the null hypothesis. So fourth step is to compare the p-value with alpha, and then we have to decide whether we reject the null hypothesis or fail to reject the null hypothesis. Okay, this is something that we need to do in fourth step. Compare the p-value and the significance label, and then mention that whether you are rejecting the null hypothesis or fail to reject the null hypothesis. Then the last step, after you know whether you are accepting the null you are rejecting the null hypothesis or you fail to reject the null hypothesis, then you can state the test. You have to write the result for the test. So what do you get after performing the hypothesis testing? So you are going to write the conclusion, and with that you will end the hypothesis testing. So that is or those are the 5 important steps that we must follow while performing hypothesis testing. Now, the first type of test on hypothesis testing, it is called the z-test for mean. So whenever we are working on z-test for mean, there are a few things that we need to know. The first one is z-test is a statistical test for mean of a population. So it is about the mean of the population. So we want to make conclusion about the population mean. If we want to make the conclusion about the population mean, we'll be using the z-test. And this can be used either when there are two cases, either when the sample size is greater than or equal to 30 or population is normally distributed. This is the first case. This is your first case. To use the z-test, the sample size must be greater than 30 or population is normally distributed. And the second case is the population standard deviation is known. Population standard deviation is known. Then to find the test statistic, the formula for the z-test, that is to find the test statistic, is given by this formula. Because while performing the hypothesis testing, we need to calculate the test statistic. Test statistic. So test statistic is given by this formula. This is the sample mean minus the population mean divided by the population standard deviation divided by square root of n. So when sigma is given, we'll use this formula. If sigma is not given, it will be a little different case. But this is the first case that we are exploring. We'll be working at 3 different cases today. And this is the first one. Make sure you write this formula or highlight that in your note catcher, because we'll be using this formula in next example. Example, a professor wishes to test the claim that the average cost of tuition and fees at a 4-year public college is greater than $5,500. He selects a random sample of 49 4-year public colleges and find that the mean to be 5,850. The population standard deviation is 650. Is there evidence to support the claim at 5% significance level, alpha equal to 0.05, that is 5% significance level? So here, let's find out what is going on. A professor wishes to test the claim that the average cost of tuition and fees at 4-year public college is greater than 5,500. So professor wants to test this claim. This is the claim. The claim is that the tuition and fee, the average tuition and fee is greater than 5,500. So the average, which is written as mu, is greater than 5,500. That is the claim. That is the claim. Okay, and he wants to test this, whether this is true or not. He wants to test that. That is the claim. Now, whenever we are performing the test, we need the null and the alternative hypothesis. Null hypothesis has equal to sign. Alternative hypothesis does not have equal to sign. So here we don't have equal to sign. That means this must be alternative hypothesis. This must be alternative hypothesis. So the null hypothesis will be the opposite of that, and it always have the equal to sign. So it will be mu equal to 5,500. That is your null hypothesis. So we have the null hypothesis and we have the alternative hypothesis. There are few additional information in the question. In order to test this claim that the average tuition and fee at 4-year public college is greater than 5,500, what this professor is doing is he select a sample of 49 public colleges. So n equal to 49. Okay. And then he found that the average of those 49 colleges is 5,850. So average cost is 5,850. With the standard deviation, the population standard deviation, by the way, which is sigma, is equal to 650. And you want to perform this test at 5% significance label, 0.05, 0.05. So this is the information that is given to us. And these are the null and the alternative hypotheses that we have written by reading the problem. We have not done anything so far. We collected the information and we have written the collected information here. Also by reading the problem, we wrote the null and the alternative hypothesis. This was the first step in performing the hypothesis testing. After we have this information ready, we have to decide whether this is the one-tail test or two-tail test. And in order to decide whether this is one-tail test or two-tail test, we look at the alternative hypothesis. In alternative hypothesis, we have greater than. That means it is the right-tail test. So this is our right-tail test. So this is the right tail. And area on the tail over here is your p-value. This is your p-value. Area on the right tail is the p-value. So this is a one-tail test. Let's write that down. This is one-tailed test. And in fact, this is right-tail test. Right-tail test. Right-tail test. Now, what we do, if you look at the steps, the second step is to find the test statistic. The test statistic is this value here. This z value is the test statistic. We need to find this value. So in order to find that value, we have the formula z equal to x bar minus mean divided by sigma over square root of n. So x bar in this problem is 5850, 5850 minus the mean. You can see mean is equal to 5500, 5500 divided by the population standard deviation is here, which is 650, divided by the square root of 49, because n is 49. Now let's subtract the numerator. 5850 minus 5500 is 350, divided by, in the denominator we have 650 over square root of 49 is 7. Now if we simplify this, 350 divided by 650 over 7 is 3.7692. So this z value is 3.7692. So that's our second step. In second step, we were supposed to find the test statistic, and we got that. That is step 2. I'm labeling the steps here so that it's easy for you to understand. Now in third step, what we do is we find the p-value. And you know that p-value is this area here. Now to find the p-value, which is the area is same as the probability. So the p-value is p-value, which is written as p is equal to this area here. So in order to find the area, we use the normal distribution in our calculator. So you can write normal CDF, normal CDF. The lower limit is 3.7692, 3.7692. Upper limit, from here it goes up to infinity. So E99, E99. Because we have the z, so this is the standard normal distribution. So mean is 0 and standard deviation is 1. Now if we perform this calculation using our calculator, we have to use our TI-84 calculator for this. If you perform this calculation using TI-84 calculator, we have to go to second vars. Okay, if you remember, you have to go to second vars and then number 2. So if you do that calculation, your results would be 0.0000819112. Make sure you try that in your calculator. So after we have the p-value in third step, our fourth step is to compare the p-value with the alpha. So clearly you can see that the p-value is 0.00008192, which is smaller than 0.05. So what we get here is we got p less than alpha. We get p less than alpha. So whenever we get p less than alpha, we reject the null hypothesis. So what we do is we reject null hypothesis. We reject null hypothesis. So very important for you to note in this step, in step 4, this is our fourth step, we compare the p-value with the significance label. And we found that the p is less than alpha. Whenever we have p less than alpha, we reject the null hypothesis. We reject the null. We are not taking this. We are rejecting this. Okay, we are rejecting this. We don't like it. We reject that. So I'm going to give cross to that. We reject that. So once we reject this, we are taking this one. We are taking the second one. We are supporting the claim. We are rejecting the null hypothesis. Meaning of that is we are taking this one. We are taking the alternative hypothesis. We are going with the alternative hypothesis. Alternative hypothesis has the claim. That means we support the claim. That is, at 5% significance level, there is enough evidence to support the claim that the average tuition and fee at four-year public college is greater than 5,500. So that should be the conclusion in fifth step. So let's write that conclusion. So in fifth step, we have the conclusion. There is enough evidence to support the claim at 5% significance level that the average tuition and fee at four-year public college is greater than 5,500. That is our fifth and the last step where we have the conclusion about the claim. T-test for mean. The t-test is a statistical test for mean of a population. So this is also the test for the mean of the population, and it's used when the population is normally or approximately normally distributed and sigma is unknown. So the key here is we use the t-test when the population standard deviation is unknown. If population standard deviation is unknown, we use this test. So you can write this down. We use t-test when the population standard deviation is unknown. And when we perform the t-test, we have to calculate the statistic. In order to calculate the statistic, the t-value, we use this formula. T is equal to x bar minus mean divided by, we don't have the population standard deviation. Instead, we'll have the sample standard deviation divided by square root of n. This is the test statistic in this case. Test statistic. And because we are calculating the t value, this is the t distribution. So we need the degrees of freedom. Always remember the degrees of freedom is n minus 1. Example, a researcher found that a cigarette smoker smokes on average of 31 cigarettes a day. Try to understand every little sentence here. So after collecting the data and finding the average, a researcher found that the average number of a cigarette smoke on a day is 31. Look at that number. It's 31. And she feels that this average is too high. Somebody is smoking 31 cigarette on average. She thinks that this is too high. So that's her claim. She thinks that this is too high. That should be the claim. So in order to test this claim, because she feels, see, here is the claim. She feels that this average is too high. Okay, this is your claim. And in order to test the claim, what she is doing is she selected a random sample of 10 smokers and found the mean number of cigarettes they smoke per day and C found that it was 28. When C took a sample of 10, the average was 28 with a sample standard deviation of 2.7. Now we have to test at alpha equal to 0.05 to see whether this claim is true or not. At alpha equal to 0.05, is there enough evidence to support her claim that the average is less than 31? So that is our goal. We want to test that claim. So let's write this down. Her claim is the average. She thinks that the average is too high. That means her claim is that the average is less than 31. Average is less than 31. That is her claim. So this one contains, or this one does not contain equal to sign. That means this must be the alternative hypothesis. This must be alternative hypothesis. So the null hypothesis is mu equal to 31 is the null, because in the null hypothesis, you have the equal to sign. This is the claim. So make sure we label the claim. Make sure we label the claim. Okay, that is the first part here. Then after that, in order to test the claim, she selected a random sample of 10 smokers. So n equal to 10. And she found that the average was 28. Average 28. Sample standard deviation as, she found the sample standard deviation to be 2.7. And we have to check this at alpha equal to 0.05 or 5% significance level. Okay, that is the first part, or our first step, where we stated the null and the alternative hypothesis. Step 1. Now, once we have the null and the alternative hypothesis, we look at the alternative hypothesis. Alternative hypothesis has less than sign. That means this must be a one tail test. And because here is the left or the less than, it is the left tail test. So let's write that down. This is one tail test. Make sure we write this part. This is one tail test. One tail test. And because there is the less than, it is the left tail test. Left tail test. And also note that the population standard deviation is unknown. Sigma is unknown because we have the sample standard deviation. That means this must follow the t distribution. So let's draw the t distribution there. So we can draw the t distribution. Suppose this is my t distribution. T distribution with degrees of freedom will be n minus 1. N is 10. So this is 9 degrees of freedom. 9 degrees of freedom. And this is the left tail test. So our p value is on the left tail. This area on the left is our p value. And this is the t we are looking for. This is the t value that we are looking for. This is on the left of the mean. So this t must be negative. T equal to, we must get some negative value. If you don't get negative value, then it will be wrong. Because it is on the left, that must be negative. So second step is to find that test statistic. That's our second step. So t equal to, we have that formula. Let's write that down. T equal to x bar minus mean divided by sample standard deviation divided by square root of n. So x bar is 28, mean is 31, divided by s is 2.7, divided by square root of 10. 28 minus 31 is negative 3, divided by 2.7 over the square root of 10. If we simplify this using calculator, you should get negative 3.5136. That's your test statistic. So this value, this t which is here, that is negative 3.5136. Okay, that is your second step. In second step, we have to find the test statistic and label that properly in the distribution. We have that. Now the third step is to find the p-value. In order to find the p-value, you can see this is the probability or the area. In order to find the probability or area, if it was a z distribution, we use normal CDF, but this is the t distribution, so we use the TCDF. So if you want to know where TCDF is in your calculator, you have to go to second, then vars and number 6. Second vars and number 6. That will give you the TCDF. Let me write that here, because in next step we are calculating the p-value. Let me write that now. P-value, which we write as P, is equal to TCDF. This is how we write TCDF. And you can access that by going to second vars and number 6 in your calculator. TCDF, the lower limit, again, the lower limit is up to negative infinity. So negative E99 is your lower. Upper value is negative 3.5136. And then we need the degree of freedom here. The degree of freedom is 9. And if you paste that information in your main screen in TI-84 calculator, your results would be 0.0033. So the p-value is 0.0033. That is your p-value using our TI-84 calculator. Step 3. We are done with step 3. And in order to get this one more time, you have to go to second, vars, and number 6. Okay, once we have the p-value, the next step is to compare the p-value with alpha. You can see our p-value is 0.0033 and the alpha is 0.05. So you can see that the p-value is less than alpha. So let's write that down. So the p-value is less than alpha. When p is less than alpha, always remember, we reject the null hypothesis. We reject null hypothesis. Null hypothesis. Let's write that down. This is my fourth step. So in fourth step, what I got is by comparing the p-value with alpha, we reject the null hypothesis. I am not taking the null hypothesis. We are rejecting this. If I am rejecting this null hypothesis, I'm going with the alternative. I'm going with the alternative hypothesis. Meaning of that is I'm supporting the claim. You can see I'm supporting the claim. So our conclusion in the fifth step will be there is enough evidence to support the claim at 5% significance level that they smoke less than 31 cigarettes a day. So we are supporting the researcher's claim here. So let's write that conclusion. There is enough evidence to support the claim at 5% significance level that they smoke less than 31 cigarettes a day. Z-test for proportion. Now, if it is the case of proportion, if the percentage is given, we have to use the Z-test. And remember, whenever we are performing the Z-test for the proportion, the sample must be random. These are the condition. And in proportion, we'll be using the p hat and q hat. That's why the condition for binomial experiment must be satisfied. And in order to use the Z-test for proportion, n times p and n times q must be greater than 10. These are the conditions. And once we have these three conditions, the test statistic is given by this beautiful formula down here. You can see. We can also rewrite this formula, Z equal to p hat, that is sample proportion, minus the population proportion, divided by p, and then we have 1 minus p is q, divided by n. You can also simplify and write the formula like this. This is the formula to calculate the test statistic. We'll use this formula to find the test statistic, and then we are going to solve the problem. So this is the fundamental part that you need to know. You need to know the formula, because we'll be using this formula in next example. Let's check an example. Example, 46% of the people believe that there is life on other planet in the universe. That's the information about the population. 46% of the people believe that there is life in other planets in the universe. A scientist does not agree with this finding, but this scientist, she does not agree with the finding. So her claim is that 46% does not believe on this one. So this is her claim. Scientist does not believe this. This is the claim. We need to test that claim. He surveyed 120 randomly selected individuals and found that 48 believe that there is life on other planets. At alpha equal to 0.10 or 10%, is there a significance evident to conclude that the percentage is different from 46? So let's see what is given. So scientists said she don't agree with that. So what she is saying is the proportion is not 46, not 46%. That is the claim. That is the claim. Scientist does not agree with the finding. The finding was 46% believe there is life in other planet, but scientist does not agree with that. That is the claim. So if this does not contain equal to sign, so this must be alternative hypothesis. That means your null hypothesis must contain equal to sign. So P equal to 0.46, that is your null hypothesis. Also, there are few additional information given here. He surveyed 120 randomly selected individuals, so N equal to 120, and found that 48 believe on this, P equal to 48. No, not P equal to 48, 48 support that, X equal to 48. Okay, 48 believe that there is life on other planet. So out of 120, 48 believe that. That means you can find P hat here if you want. P hat will be 48 divided by 120. 48 divided by 120, which is equal to 0.4. So P hat is 0.4. And the alpha is 10%, or alpha equal to 0.10. So this is the additional information that we have. Okay, that is our first step. I'm going to label this. This is my first step. We have the null and the alternative hypothesis. We have the claim. And also we have some additional information. This is the first step. And also one very important thing to note here, the alternative hypothesis contains not equal to. Meaning of that is, this is two-tailed test. Let's write this down. This is a two-tailed test. Two-tailed test. So in this case, we have the area on the left tail and also on the right tail. And if we add those two areas, if we add the area on the left and area on the right, that will give you the total P value. This one, it will be positive Z score. This will be negative Z score. You have the equal value, but opposite. So we have a two-tailed test in this case. So once we have the null and alternative hypothesis set up, and we know that it's a one-tailed test or two-tailed test, here it is two-tailed test, we need to find this test statistic or the Z value. So for the proportion, the Z value is, let's write the formula. We have the Z value is equal to P hat minus P divided by square root of PQ over N. So P hat is 0.46, 0.4. You can see the P hat is 0.4 minus your P is 0.46, 0.46 divided by P hat. No, this is P, not P hat. P is 0.46 times Q. Q is 1 minus 0.46, which is 0.54. 0.54 divided by your sample size N is 120. So if we simplify this, you can see 0.4 minus 0.46 is negative 0.06. 0.06 divided by, inside the square root, you have 0.46 times 0.54 over 120. Now we can simplify this using calculator, and then the result will be negative 1.3188. So this value is negative. So this is negative 1.3188. And this value over here is 1.3188, because one value will be negative, the other one will be positive. Negative on the left and positive on the right. So that's our Z value, or the test statistic in number 2. Because in number 2, we are supposed to find the test statistic. Test statistic. Okay, that is step 2. We calculate the Z value. P value, that is third step. P value, P is equal to, so it is double this area or double of this area. It is the same thing. So I'm going to find the area on the right and double it, or I'm going to write 2 times normal CDF, because to find the area we use normal CDF. Then for the right, the left boundary is 1.3188, 1.3188. Right boundary is infinity or E99. Mean is 0, standard deviation is 1. So what you have to do is you have to go to your calculator, second verse number 2, and then put the information, get the result, and then double it, multiply your answer by 2. So if you do that, your result should be 0.3744. That is our third step. In third step, we got the p-value. So we got the p-value by using the calculator. It is 0.1872. It is the sum of area on the left tail and the right tail. So once we have this p-value, we have to compare with alpha. So fourth step is to compare the p-value with alpha. So your p is 0.1872, and you can see that this p-value is greater than alpha. So p is greater than alpha. When p is greater than alpha, you know that we fail to reject the null hypothesis. So fail to reject the null hypothesis. Fail to reject the null. Meaning of that is we are not rejecting the null. We fail to reject. We are not rejecting it. So instead we reject this one. We are not rejecting the null. That is the meaning of that. We fail to reject. So we are going with the null. We are not going with the alternate hypothesis. That means we are not supporting the claim. So in fifth step, you'll write you are not supporting the claim. There is no enough evidence to support the claim at 5% significance level. That will be the conclusion. Let's write that down. There is not enough evidence to support the claim at 10% significance level. So whatever the scientist has claimed, we are not going to support that. Instead, we are going to support the finding that the 46% of people believe that there is life on other planet.